Evaluate integral over c cos pi z square dz upon z minus 1 into z minus 2, where c is the circle, modulus of z equals 3. To get the singularities of the given function, we have to equate denominator to 0. Singularities are those points at which function fails to be analytic. When denominator is equated to 0, we obtain z minus 1 into z minus 2 equals 0, from where we have z equals 1 or z equals 2 are the points which make the denominator 0, and these are the singularities. Since modulus of z1 equals 1 and modulus of z2 equals 2, where z1 and z2 are z1 equals 1 and z2 equals 2, we have both the singularities lie inside the circle modulus of z equals 3, because these two singularities have modulus less than 3. Now f of z equals cos pi z square is an analytic function. Now we have 1 by z minus 1 into z minus 2 using partial fraction method, written as a by z minus 1 plus b by z minus 1. When you take LCM on the RHS, you have a into z minus 2 plus b into z minus 1 upon z minus 1 into z minus 2. Both LHS and RHS have same denominators, so they can be cancelled, and we have z times a plus b minus 2a minus b in the RHS equals 1 in the LHS. If you compare coefficients of z on both sides, you have a plus b equals 0, because here there is no term of z, therefore coefficient of z is 0. Here coefficient of z is a plus b, therefore a plus b equals 0. Now if you equate constants on both sides, you have negative 2a plus b equals 1. From this equation we have a equals minus b, and from this equation you have 2a minus a equals minus 1, because when b equals minus a, which follows from this equation, you can write positive b by minus a. Therefore 2a minus a is obtained here. If you multiply both sides by negative sign, you obtain 2a minus a equals negative 1. From here you have a equals negative 1 and b equals 1. Therefore by partial fraction method, we have 1 by z minus 1 into z minus 2 can be written as negative 1 by z minus 1 plus 1 by z minus 2. In order to evaluate integral over c cos pi z square dz upon z minus 1 into z minus 2, it's enough to evaluate the sum of these two integrals. We have negative integral over c cos pi z square dz upon z minus 1 plus integral over c cos pi z square dz upon z minus 2. These splitting we could arrive at, because here we found 1 by z minus 1 into z minus 2 equals 1 by z minus 1 plus 1 by z minus 2. If you multiply both sides using cos pi z square on the numerators and you apply the integral signs, integral dz, then you get back to this same expressions. We have by Cauchy's integral formula, integral over c f of z dz upon z minus a equals 2 pi I f of a, where f of z is analytic function. Therefore we have these two integrals can be written like this, that is negative 2 pi I into f of 1 plus 2 pi I into f of 2, because we already found f of z equals cos pi z square is analytic function. When you give z equals 1, you obtain cos pi, therefore f of 1 is cos pi. When you give z equals 2, you obtain f of 2 equals cos 4 pi. Therefore this given integral becomes minus 2 pi I cos pi. We have cos pi equals negative 1 and 2 pi I cos 4 pi. Cos 4 pi is positive 1. Therefore we have 2 pi I plus 2 pi I, which equals 4 pi I is the value of the given integral to be evaluated.